Hi everyone, welcome to my talk, Solving the Issues of Mysterious Database Benchmarking Results. And before diving into the technical details, some words about myself. So I'm Daniel. I have an academic background, did my PhD in computer science at the Ulm University in Germany. The research was basically focused around evaluating distributed systems, especially distributed database systems that are operated in the cloud. And after finishing my PhD, together with my co-founders, we started benchANT, a benchmarking as a service platform for database systems where I'm responsible for the product development. And obviously, I can pursue my interest in benchmarking database systems. Having said that, today's talk is centered around, database performance and how you can assure to achieve reliable and reproducible and transparent performance measurements. And in order to address that, I will briefly go over first the question, is database benchmarking still relevant these days? Second, highlighting some challenges of reliable database benchmarks, especially in the cloud. In the third part, I'm going to do a short demo based on our open database performance ranking before concluding with some takeaways. So let's start with the first question. Well, is database benchmarking still relevant? And well, we're all here as we know a lot about databases since we're interested in database systems, especially high performance database systems. And there was also, tremendous change over the last decade when it comes to the database landscape. First of all, the idea of one size fits all is over. We have still the relational systems, but we have the NoSQL, we have the new SQL ones. And well, they promise you to provide the perfect solution for your data intensive application. Second, these database systems are nowadays preferably operated in the cloud and not on physical resources anymore. And together with these two, tremendous changes, there is also a third fact that is now, or reached the mainstream. Database as a service, and especially serverless database as a service, is already out there, provided by a lot of database vendors, but also cloud providers. And this might be the future of the database world. And with these, significant changes, there come a lot of options for selecting the right database technology for your data intensive use case. And well, all the providers, when it comes to performance, promise you a similar thing. They promise you high performance, unparalleled performance, and so on. But as a user, you actually might want to verify these claims. And in order to do so, well, you need some data to verify these claims. And where can you get these data from? Well, let's have a look. So first of all, you will find a lot of information about the functional features by just reading the docs of the respective database technologies. When it comes to the costs for operating them in the cloud, you will have to do some data mining due to heterogeneous pricing models of different cloud vendors, but also database vendors. But the interesting part, actually, the performance and the scalability of the system, well, there it gets tricky. You could, of course, ask Google or ask ChatGPT nowadays if or what kind of performance the respective system is going to provide. And you will find, well, blog posts, white papers, or even scientific papers about that. But there are always problems with that. So they might be already outdated due to the rapidly evolving technology domains. They might be biased or vendor driven, but all of them have some thing in common. So most likely they won't provide you all the data to fully understand the performance result or even to reproduce the performance results. This is why benchmarking is still a challenge, but you can also get a lot of insights out of it if it's done right. And that's also something that the academic perspective recently highlighted by the report on database research. Well, highlighted again that database benchmarking has been around a long time and it helped the industry, but also the database research community. It also highlights that benchmarking in the cloud adds another layer of complexity and makes it even harder to provide or to enable fair comparisons across different technologies. There is also an industry view on benchmarking database systems. Basically, all the big players on the cloud market or on the database market highlight the need for running benchmarks by yourselves in order to have an application specific view on the data that you can get out of that. And before doing any decision when it comes to selecting a database systems, you should thoroughly measure everything with respect to database technologies, but also respect to the available cloud offers. And the same approach goes when performance engineering companies such as Percona address performance problems. Well, you should do it in a systematical way and not just ask Google. And with that, we basically can already answer that database benchmarking nowadays is still relevant, maybe even more relevant than it was before, since the cloud adds another layer of complexity, and you want to get in-depth measurements to understand the performance impact. And with the benchmarks, you can not only compare different database technologies, you can do a lot more. So, for example, comparing the cloud provider performance, doing a lot of load and stress testing with respect to scalability and elasticity. That's an important aspect for serverless DBaaS offers. You can also do application-specific database optimizations by tuning the configurations and measuring the impact. Keeping track of new releases, new cloud resource offers, and this always offers the option to lower your TCO by running benchmarks in order to find a more cost-efficient solution. But running these benchmarks in the cloud comes also with some challenges. In order to highlight them, I will briefly go over the typical process when you run benchmarks in the cloud. So there are basically 4 steps: allocating the resources, deploying, configuring the cluster, deploying, executing the benchmark, and processing the objectives. But each of these steps involves a lot of domain knowledge for the respective step. So for the cloud, we have now a plethora of cloud resource offers. So example, for over 500 even on EC2, not counting all the other publicly available cloud offers. When it comes to the databases, there are over 850 database systems available, thanks to the database of databases provided by the Carnegie Mellon University, keeping track of this evolvement. Nowadays, we also have already over 170 DBaaS offers. So for example, right now there are over 10 DBaaS offers providing a service for Cassandra query language compatible services. When it comes to the database benchmark, actually, there are also different benchmark suites available. These benchmark suites will allow you to carry out several workloads from IoT-based to web-based to analytical workloads. And when it comes to the objective, so usually you evaluate performance or performance versus cost, but also scalability and availability. So doing that all manually is very time consuming, very, very error prone. And since this whole process is not just one shot, it's an iterative process, the first thing you need is automation. Because without an automated benchmarking process, you won't be able to run large scale studies or keeping track with the rapidly evolving technologies. But good thing is that especially over the last 2 to 3 years, there were several approaches towards automating the benchmark process for database systems in the cloud. So for example, there is the great tooling by ScyllaDB. There are also approaches by MongoDB that are published in different scientific conferences. There is another scientific approach, the FlexiBench, for running benchmarks of different database systems on Kubernetes. There's the Mowgli framework that was the project that I was working back in my research days. This is an open source tool for running benchmarks for databases in a multi-cloud context. And it's also the foundation of benchANT that builds on top of these concepts and provides a benchmarking as a service platform for database systems. But with the automation, it's not done, so to say, because with the automation of the process, you get a deterministic execution, which is already a good thing. But in order to have it fully transparent and fully reproducible, you will need a lot more data. Here, I just put 4 example questions that usually pop up when we look at benchmark results. So there is a lot more data that needs to be covered. In particular, for each step, so for the cloud level, you need to collect also cloud provider and the resource metadata on the database level, which configurations were applied, and also how was the system utilization in order to avoid some bottlenecks imposed by the benchmark setup on the workload level. Which fine-grained workload configurations were applied, for example, data set size, query distribution patterns, and so on. And for the results, of course, you should not only provide the aggregated results, but also raw measurements in a time series based manner. And all of this needs to be compiled in a comprehensive data set to ensure, or that ensures then a transparent and reproducible results. And this is also something that we at benchANT, this concept, is followed by our platform. And in the following, I will briefly show some as a demo our open database performance ranking that contains a lot of performance data. And I'm going to demonstrate how we achieve to ensure transparent and also reproducible results with it. But before jumping into these performance numbers, just a short disclaimer. The ranking is not intended to make your final database decision upon. It's just a very, very baseline for starting application-specific benchmarks. And there are also some other aspects that are not covered yet, especially all the workloads are based on synthetic benchmark tools with a rather small data set size. Feel free to play around by yourself with the ranking or have a look at it. It's completely open source, available on our website. And I'm always happy to answer any questions that pop up regarding the ranking. So just drop me an email. And with that, I will briefly jump over to the ranking. So what we did is we measured the performance of different database systems on different cloud providers on 3 workload types. You can find all the details below. I will just show now the results for ScyllaDB, where we had different scaling sizes ranging from 1 node to 9 node. And what you can get out of the ranking is, so for example, you get the throughput, the average throughput, read latencies, write latencies, also the monthly costs to operate that cluster on the respective cloud provider, and a throughput per cost ratio. You will also get some more details, what kind of version. Here we haven't included the latest 5.1 yet. It's up to be released. You can find some details on the cloud. And yeah, so from the smallest scaling size to the largest, we also see that we have a great scalability of Scylla here. And yeah, just a few more insights that you can get is, so if we add some other NoSQL and NewSQL systems here, then you're going to see that well, Scylla outperforms them all on AWS for this specific workload with this specific configurations. So Cassandra, Couchbase, and even so Cockroach is way more down. So this is one of the insights that you can get out of the ranking. Second one is you can also use it to compare the performance of different cloud providers. So here, for example, I filtered it that Cassandra, same scaling size, but operated on different cloud providers. And yeah, here we see in that case that Alibaba, they're pretty similar all, but in that case, Alibaba did a good job compared to AWS and the others. You will also spot some results where, for example, Azure provides really low performance, and yeah, but feel free to play with it by yourself. Interesting part is also here that all the data is available on GitHub. And here we not only provide the performance numbers, but all the applied configurations. So all the things that can be played with during a benchmark execution. We have as well monitoring data. We have the cloud provider metadata, the virtual machine metadata, so you can see which operating system, which kernel version. You get a lot of database metadata, so configuration files, cluster state, and so on. And we can also say that with that data, well, you can use it via our platform to reproduce the results, or you can rebuild the benchmark process by yourself by that data and reproduce the results. Had also been done by some database vendors which were not happy about the results, and they did it by themselves. And okay, then they had to agree that with that data they were able to get the same results. So switching now back to the slides. So with that data, we actually able to provide you reproducible and transparent benchmark results. And in summary, we can say that database benchmark can support a broad range of use cases from cloud resource selection, database tuning, database comparisons. That running database benchmarks in the cloud in the first place, it's easy, but ensuring transparency and reproducibility is hard. And a step towards that is to have automated benchmark executions by using a supportive framework or tooling. And in addition, the results need also to include comprehensive metadata to ensure the reproducibility. So I hope I got you interested in what is required to ensure transparent benchmark results. And I also hope to get you to know what you need to look for when the next time a white paper or blog post comes up about some database performance results. Thanks a lot for attending my talk.